All right, this is homework one, question number two. So here we have three charges at the corners of an equilateral triangle as shown in the figure. And and the charges are given. We want to determine the net force on Q1. So that's this position here. So what's acting on that position here is Q3 and then also Q2, right? So we can draw the actual forces acting there. First, let's start with the easy one, Q2. Here we have a minus charge at Q1, and the Q2 is positive, so it's going to be an attractive force. So we can draw our, sorry, I need to zoom in, otherwise my handwriting is really bad on the iPad. So we can draw our force here, F2, as such. And then with Q3, we have a negative and a negative, so it's going to be repulsive. So you can just kind of like imagine tracing this line down and the vector will be coming out that way. I'll call that F3. So let's just do a coordinate system here. I'm just going to do standard coordinate system as such. And we know, from 135A, we should break down F3 into its components, right? So let's do that real quick. Okay. And angle theta, we'll put that right here. The alternate interior, angle theta right here. It's an equilateral triangle, so theta equals 60. Okay. Here, I need to, sorry, my computer's old, so I need to turn the fan on. I have like an external fan, otherwise it overheats. Okay. So, sorry about that. We now have the components. First, the x component, F3 touching the angle theta, cosine then, theta. And then the y component pointing in the negative direction from what we defined. So it's F3 sine theta. Okay. Free body diagram is complete here. So in part, it's just one thing now. So in part A, I'm just going to call it just so we can move along. We're asked to solve for the net force. So F net is what we're solving for. F net is what we're solving for. So what does that consist of? That consists of F net x squared plus F net y squared, right? And then, Pythagoras, you're going to take the square root. I'm going to start with the x direction here. Sorry, guys, this is a new iPad. It's really exciting for me, but also I'm getting used to the writing here. So F net x. So what's acting in the x direction? Well, simply we have this one. I think I can, yeah, I like the tail of it. So we have this one, right? In the positive F2 in the positive x direction. So F2. And then, but that's not it. We can also see that F3 cosine theta is in the negative x direction. Therefore, minus F3 cosine theta. Remember, forces and fields, we don't plug in the negative, but rather we allow the direction of the vector relative to our coordinate system to tell us what is plus and what is negative. We define this as the plus direction. So therefore, F2 is plus and F3 is minus. Now we have to work everything out. I'm going to skip the calculator steps. I'll let you plug into calculators on your own. And so yeah, you guys can have fun doing that. And then minus, okay, the charge acting on the position, Q3 on Q1, divided by r squared. This is our x component, cosine theta. At this point, all you would need to do is solve and plug in. Well, I'll kind of give you guys a little quick tip. Just try to factor out as much as you can here because this can take a while to plug into your calculator on the exam. You're going to want to work with speed, huh? So that's a little way you can speed that up. And now we can look at the y direction. And let's see what's acting in the y direction. Nothing by F2. F2 is purely in the x. However, with F3, we have F3 sine theta pointing down in the minus direction. So minus F3 sine theta. Okay. Same order of business in which you adjust the equation as. So that's going to be K, Q3, Q1 divided by, sorry, I keep having to admit people into the Zoom, over R2. Oh, goodness. Over R2 sine theta. And again, I'll leave it to you to plug everything. the next thing you need to do is, we're working with Pythagoras. We have to establish a triangle. So clearly, well, I know what the answer is going to be. So f net x comes out to be a negative value. So that's a little spoiler alert. So I'm going to call it minus here. And then this comes out to also be negative value because there only is a negative here. So when you draw your f net to solve for f net total, right, you need to, redraw your triangle. So f net x, that being this guy right here, comes out as a negative. So therefore, it's going to point in the minus x direction, f net x, and f net y. And, obviously this one comes out as negative because there's only a negative here. Comes out as negative, so it's also pointing in the negative direction. So you can solve for f net total, that guy right there, solve for alpha. You can, so you solve for this one using Pythag. You can solve for alpha using any of your trig functions, and then you will come out with the total magnitude and the direction. And you would have to specify with the direction. It'll be some angle below the minus x-axis, right? We define this as the minus x-axis, and we're going to be some angle below it. All right, so that's question 2. All right, now for Q6 here, we have 3 charges, and they're all placed at the corner of a rectangle shown in the figure. We want to determine the electric field at point P. Okay, so we have to remember with these electric fields, we have to treat, it's just, we're looking at some position in space right here, and we treat it as if there's a plus charge there. So just for sake of going in numerical order, here, I'll do that actually in a different color. Let's do it like this, so I can be very clear about my drawings. We treat that as a plus test charge, although there is actually no charge there. But what happens is there was a, imagine this is like a plus area here. There will be an attractive force because this is minus. So that means E1 will be pointing towards Q1. Conversely, with Q2, a plus acting on a plus will cause it to be repelled. So we would say E2 like this. And again, we can see why E3 is pointing towards Q3. I'm just going to use a standard coordinate system here. We know to break E1 into its components, like this, and like this. You can solve for this angle theta, because we'll say tan theta is equal to 0.03 divided by 0.04. Okay, and I'll tell you what that is. That's equal to 36.9 degrees. Okay, and you also need to solve for R, where R is this, the position between these 2 green dots. So let's call this R. All right, and actually, if you're really have a good eye here, you'll see that it's equal to 0.05 meters. Okay, so it's now from here, it's just kind of very similar to what we just did, except we just have a new equation and we're using E net. So, you still are going to need to solve for the E net total. So that's going to constitute of the E net in the X direction plus the E net in the Y direction, square root that, Pythag, what's acting in the X direction. So we have E2 in the positive X direction, and then we have a minus E1, and it's going to be cosine theta. Again, that's because it is touching the angle theta. I say touching, I mean, like here's the angle theta, its vector is touching like the bottom of it. I don't know. That's just how I remember it. So we'll say E net X is equal to E2 minus E1 cosine theta. Okay. And where, E2 is going to be equal to K Q2 over, what's that? 0.04 squared minus K Q1 over 0.05 squared cosine theta. All right, and I'll leave the rest for you to solve. And then E net Y, let's see what's acting in the y direction. Well, we have E3 pointing straight upwards, and we actually have E1 sine theta pointing straight upwards. So that means we have a sum of vectors. So E3 plus E1 sine theta. And then, same process, factor out where you can. So, with this one, for instance, you'll be able to factor out k. And yeah, then I think at that point, it's just like how we solved above and very similar to 135a. I don't want to give everybody everything here, but that's a nice hint there. Okay.